This is Module 3 of our Basic DC System Testing and Maintenance course. This section and module will cover NETA acceptance testing requirements. This training is the third of 5 modules. Though it is probably the shortest, its importance to acceptance testing and commissioning cannot be overemphasized. Completion of the modules and exams will provide the knowledge factors required for CEUs. Additionally, there are practical factors that must be completed in a lab simulation or on the job. Completions of these practical factors will provide a certification in basic DC systems. This certification means the trainee is capable of executing basic testing and maintenance on battery cells, cell lines, known as battery banks, and chargers. The trainee should follow along in the trainee guide. The exam links are in the electronic version provided. Let's take a look at our course objectives with emphasis on the objective for this specific module. Upon completion of the entire course, you should be able to explain the basic terminology and theory associated with electrolytic cells. Explain DC system safety associated with electrolytic cells and cell lines. And for this module, describe the acceptance testing procedures associated with electrolytic cells and cell lines. Additionally, as we move forward, we'll cover the maintenance inspection and testing associated with electrolytic cells and cell lines, and the characteristics associated with lead acid and nickel cadmium batteries specifically. The following acceptance testing information is derived from industry standards, specifications, and practices, including NETA, IEEE, and manufacturer's instructions. Additional specifications may be required by the owner and should be reviewed. Many of the testing and inspection details will be expounded on in the final 2 modules covering the maintenance. The maintenance information should be thoroughly understood when executing acceptance testing and inspection. Finally, the most important document to govern initial installations will be the manufacturer's instructions. First, let's look at the NETA requirements for visual and mechanical inspections. First, we need to verify the batteries are adequately located, that the battery area ventilation system is operable, and verify the existence of suitable eyewash equipment. Next, we want to compare equipment nameplate data with drawings and specifications. The data on the nameplate of the batteries and the chargers should match our specifications and drawings. If there's any discrepancy, this needs to be noted and brought to the attention of the owner. Inspect physical and mechanical condition. Quite often when things are shipped, they run into problems in shipping, they get dropped, they get mishandled. And part of our inspection, especially on new installations, is to inspect and make sure that they were properly received, the equipment is in good order, and also that they were properly installed by the construction company. We need to verify the adequacy of battery support racks, mounting, anchorage, alignment, grounding, and clearances. Next, we verify that the electrolyte level and measure the electrolyte specific gravity and temperature levels. Identify and note the pilot cell. This does not apply to valve regulated batteries. So what is a pilot cell? It's one cell in one battery bank, and it is usually selected as a pilot cell for specific gravity readings. After the initial charge, or to begin a yearly cycle, choose a pilot cell from one of the lowest specific gravity and/or lowest voltage cells. This cell is used as a representative for readings for 1 year. Each year, a new pilot cell is chosen. Verify the presence of flame arresters. As with a few other things that we're going to be talking about as we move on with differences in types of batteries, the flame arresters do not apply to nickel cadmium or valve regulated acid batteries. Verify the units are clean. Inspect spill containment installation. This does not apply again to valve regulated lead acid batteries. Next, we need to verify the application of an oxide inhibitor on battery terminal connections. We need to inspect bolted electrical connections for a high resistance using one or more of the following methods. and actually both are the best way to proceed. Use of a low resistance ohm meter after you have verified the tightness of accessible bolted electrical connections by calibrated torque wrench method. And again, the manufacturer's instructions should be referred to when we're dealing with these connections. We're now going to look at the electrical tests that are required as part of the NETA acceptance testing. We need to measure the charger float and equalize voltage levels. Adjust to the battery manufacturer's recommended settings. Keep in mind, different types of batteries have different float voltages and equalizing voltages. The manufacturer's data is our primary and most important source for setting the charger at its float and equalize level. Measure negative post temperature on VLRA batteries only. Verify all charger functions and alarms, ground alarms, low voltage alarms, AC alarms. Battery chargers vary a lot from one manufacturer to manufacturer on what alarms they have and what those alarms do. You should go to the manufacturer's instructions and verify all existing alarms. Measure each cell voltage and the total battery bank voltage with the charger energized and in the float mode of operation. This is the way the bank will be in operation for most of its time and most of its existence other than when having maintenance done on it. Again, total battery voltage and each cell voltage with the charger energized and in float mode. Cell voltages shall be within 0.05 volts of each other or in accordance with manufacturer's published data. Measure each monoblock/cell voltage and total battery voltage with the charger energized and in the float mode of operations. This applies to valve-regulated lead-acid or VRLA batteries only. Monoblock/cell voltages shall be in accordance with the manufacturer's published data. Let's look at this term monoblock. The term monoblock refers to a battery with multiple separate but electrically connected cell compartments, each of which is designed to house an assembly of electrodes, electrolyte, terminals or interconnections, and possible separators. A 12-volt car battery is an excellent example of a monoblock battery. Measure intercell connection resistances. Using these, you need to compare them to the bolted connection resistance values to values of similar connections. Investigate values which deviate from those of similar bolted connections by more than 50% of the lowest value. Perform internal ohmic measurement test. Cell internal ohmic values, whether it be resistance, impedance, or conductance, shall not vary by more than 25% between identical cells that are in a fully charged state. Perform a load test in accordance with manufacturer's published data or ANSI IEEE. This is also referred to as a battery capacity test. Measure the battery system voltage from positive to ground and negative to ground. Voltage measured from positive to ground shall be equal in magnitude to the voltage measured from negative to ground in a typical ungrounded battery system. As we conclude, in all cases, when executing acceptance inspections and testing, refer directly to engineered design and manufacturer specification and instructions for both the batteries and the charger system. Reviewing our course objective, upon completion of this session and this module, you should be able to describe the acceptance testing procedures associated with electrolytic cells and cell lines. This concludes Module 3 of the Basic DC System Testing and Maintenance course. If you have any questions or need clarification on information in this module before you take the exam, contact the instructor. You should now refer to your trainee guide and take the exam. If you fail, the instructor will receive an email and contact you for course remediation and retake. Thank you for the time, and I hope this has been helpful, this lesson on basic DC system testing and maintenance course, specifically Module 3, associated with NETA acceptance testing and requirements. Have a safe and healthy day.